Swayam Prabha. Digital India. Educated India.
Next we'll look at another control source, which is the voltage controlled current source. And this is given by a symbol which is similar to a current source, but again we use a diamond instead of a circle to distinguish independent sources from controlled sources. And also we have to have controlling nodes. What this says is, if the voltage between let's say N1 and N2 is Vx, that will cause a current some G times Vx to flow from N3 to N4. Okay, so now this G obviously has dimensions of conductance. Okay, because it multiplies a voltage and results in a current, it has dimensions of conductance. Okay, sometimes this is called the transconductance of the voltage controlled current source. It's common to abbreviate voltage controlled current source as Vccs, similarly for all the other control sources. Okay, so again, because this current is G times Vx, which is a linear function of Vx, this control source is linear. As I said, all the control sources we consider will be linear. Now what does this mean again? Let's say we had a voltage controlled current source, let's say given by G equals 1 millisiemens. It means that if I apply 1 volt on this side and let's say the other side is connected to some circuit, okay, it causes a current of 1 milliamp to flow over there. Okay. Now, as I had mentioned while discussing independent current sources, just drawing current source like this with open circuited nodes is not legitimate because it violates Kirchhoff's current law, but it's cumbersome to keep connecting some arbitrary circuit. You have to imagine that if this is connected to some circuit, it causes a flow of a certain amount of current given by the value of the either the independent current source or the controlled current source. Okay, and sometimes this controlled current source is also known as a dependent source. Okay, because the value of the control source, whether it's voltage or current, depends on some other variable in the circuit. Okay, again, this voltage controlled current source does not correspond to a physical element like a resistor, but it's a model for something, and it turns out that a voltage controlled current source is a good model for many active devices such as the transistor. We won't be discussing that here, but later when you come to transistors, you will see that the behavior of the transistor under certain conditions is well modeled by a voltage controlled current source.